Hey, what's up, everybody? We're here with Dave Rowland, who's the lead developer for Tracktion and Waveform. Waveform and Tracktion are kind of the same thing, aren't they? And so he's going to tell us a little bit about himself, and we're also going to talk a little bit about the Tracktion engine, which was released a couple months ago and has been making waves in the audio development arena. And he's going to tell us a little bit about it, being that him and Jules were the main ones working on it. So how you doing, Dave?
I'm pretty good. Thanks for having me on, Josh. Hope everything's good with you.
Yeah, so this has been a talk that's been kind of a long time in the making. We've really kind of talked about doing this since probably even before Tracktion Engine got released. You know, people really see you as a very influential audio developer within the industry. I know you laugh at that, but you're very highly regarded. And you know, one of the talks that often gets cited. So there are a few kind of talks that are very kind of cited quite often within the audio development community. So one is Teamer's audio development talk. I think it was 2015 at CPP-Con. So that's like a very kind of iconic talk, and yours is right up there with it. I believe it's the 2017 talk on the value trees, the value tree talk. So that one is also cited as very often as a very kind of iconic or, you know, very informative and influential talk. So yeah, so you're very highly regarded, in case you didn't know. So
that's a good company to keep with Timor.
Yeah,
I think they could actually, because Timor's was possibly the first or one of the big audio talks at CPP-Con, which is there's like 150 odd talks there and lots of high-ranking C++ developers, so having an audio talk in that arena was great. Yeah. And he kind of focused on a lot on, you know, the background to audio, why it's different from other industries, and some of the kind of hardcore multi-threading stuff. And then the ADC one that you mentioned was, I don't know if I kind of said it at the time, but it was basically around how we built the Tracktion engine. So it's a very kind of high-level app model-based thing. So you know, watching both and piecing together the missing bits, it was kind of like a good thing to do. And hopefully now you can see the Tracktion engine code, you can kind of see how those two sides meet in real life.
Yeah, that's great. And as we discussed before, I think that it would be really cool just to let people know just a little bit about your history, how you got into the position that you're in now, how long you've been developing for, what got you on into development. So I guess we could start at the beginning. What is there something in particular that got you into audio development? Did you used to produce, or did you play an instrument?
So when I was younger, I used to play guitar. I think I started relatively late, about 15 or 16 or something. And you know, just playing with friends and things, and got really into it. And then when it was time to decide whether I wanted to go to uni or something, I thought, well, I'd always been sort of relatively good at science and math subjects. So I thought, is there something that I can do that has musical elements to it? So I ended up looking at a few university courses, and one that kind of seemed to meld these two elements really well was the music systems engineering degree at UWE, University of the West of England. So I went there and did that, and that was a great course because it gives you a bit of everything. There was some analog electronics, there was some digital electronics, there was some studio practice, there was some music theory, and there was a bit of software development as well. And in the first year, it was more straight down the line C development, and I hadn't done any programming up until that point, so it was a real shock. It was just like, I have no idea what's going on here. And then as the years kind of progressed, we did more audio development stuff. We did some signal processing and DSP, and then started making some effects plugins and audio units, and also got introduced to Max MSP, where we did some synthesis stuff as well. And I just kind of really gravitated towards the more programming elements of it, really. And when I came to do my kind of final year project, I ended up doing a sort of synthesizer in Max MSP that was kind of like a modular thing, because I enjoyed it, really. And then when I finished that degree, I immediately went on to do a master's, but I did it part-time, so I was working in bars and things as well. And the master's was kind of like a step up, but I focused more heavily on the kind of C++ programming side of things, and that's where the program leader on that was Martin Robinson, who you may know from the industry. He's a guy to know. And
by the way, Martin, I was just going to interrupt. Martin's got, I think, the only Juice book that's out there on the market, and he's big shout out to Martin if you're listening.
Yeah.
So go ahead.
And he introduced me to Juice. So that was the first time we kind of got into Juice, and that kind of really opened up the world of what you could do relatively quickly in programming. So that was a really good thing to do, and I just kind of focused heavily on the software development side of things through that, because I did it part-time. I think it took me 2.5 years. Then after that, I immediately jumped into, I did 2 jobs at the university, actually. I did some support desk help, so, systems admin kind of stuff. And I also, Tom Mitchell, who worked at the university and was leading some modules at that point, he said, "You want to come and teach on some of my undergrad modules?" So I ended up teaching the modules that I had kind of studied about 3 years previously, which was really great. They always say, if you really want to understand something, teach it. And that really kind of pushed my understanding of some of the key principles. I think that's kind of lasted with me today. And what's really great about that is I ended up teaching some of the people that I now work with. And so it kind of just goes this full cycle thing, which is really cool. Then after that, at the same time, I started doing a few freelancey bits of contracts, but just kind of small things. Then I went away and had a break, did a bit of traveling, and then I got an email from Jules saying, "Hey, I've seen some of your code," because as part of that years I created this DAW audio module. And he said, "I don't hate your code. Do you want to come and," which is high praise to do. So then he said, "Do you want to come and work with us on Tracktion? We're relaunching it with a new company." And I was like, "Yeah, that sounds awesome." So I flew home from my holiday, and I started kind of part-time there, but then quickly ramped up to full-time. And then when Jules moved to Rowley, I kind of took over sort of the head of software role at Tracktion. So that's kind of the story. I've been doing that for sort of 6 years now.
Amazing. That's a very Jules statement there. I don't hate your code. Big shout out to Jules. Wow.
Yeah, she's like, it's a hard taskmaster, but it kind of drives you forward. It worked with me.
And how much of an adjustment was it for you when you first started working with Jules? And of course, everybody knows Jules as a creator of Juice. And when you first started working for him, was it a really steep learning curve, or did you feel that you were hanging in there? Or?
No, it was absolutely huge.
Was it?
The scale of things, like if you're doing kind of toy projects, as I would call them, like hobby type things, you're probably looking at like, I don't know, 5,000 to 10,000 lines of code. So you can kind of keep everything in your head all at one time. Then when I started working on Tracktion, it was about 180,000 lines of code. Plus you've got all of Juice on top of that, which is several 100,000 lines of code.
Yeah.
And it's a DAW, as far as the projects I've seen, is like the most complicated thing you can do, because it's got an incredibly complicated data model. It's got third-party plugins that you kind of disappear into and come out of. You've got hard real-time audio stuff. You've got MIDI threads being injected, and then you've got a really complicated UI, and it all needs to work really intricately together. So I'd never really done anything like that before, so it was a massive step up.
Yeah.
But I think that's good. It was nice to be exposed to, this is what real world software looks like that you use on an everyday basis, compared to just kind of getting by with doing things before.
Wow. Amazing. And so you've been working there for 6 years now. Is that
yeah,
right?
It's six or seven.
Nice. And really it's you and Rowland that really handle all of the development side for Tracktion nowadays. Is that correct?
These days.
Yeah. Wow.
Yeah. So Jules does a bit of stuff. Typically, if we're doing kind of engine architecture stuff, he might come in and do a bit, or we'll kind of chat about how should this thing look. But on a day-to-day basis, me and Rowland Rabin, also we just do it all pretty much. There have been other people kind of doing bits and pieces in the past, but we're the core team.
Yeah. Okay. And I think that's a good place for us to segue into just maybe the history of Tracktion and how Juice and Tracktion relate, and how these. So you touched on that before. Can you just maybe run through a good history of what's happened there, just so people.
Yeah. So to the best of my knowledge, because I obviously wasn't around back when Jules started writing Tracktion, but I have checked this with him, so it is right. So Jules started writing the Tracktion DAW, as it was, back in 2001. And I think the original idea was, DAWs are complicated. All I want to do is play my guitar and record it, and that to be a really easy process. So he kind of started with that ethos, and that's why Tracktion originally was quite different from everything else around back then. So I think he took about 2 years working on that, and released T1, the first version, in 2002. And then in 2003, he sold Tracktion to Mackie, because they wanted a piece of software to distribute along with all their hardware. And Rowland Rabin, who we mentioned earlier, who now works with us, was working at Loud at that time. So he kind of took on working on Tracktion in 2003. And I think Jules and Rowland worked on T2 together, and then I think Rowland did T3 on his own and maintained it for a number of years. So when it kind of moved over to Mackie, Jules took the application and kind of all the utility classes and stuff, and all the GUI framework that he'd kind of created for this, and spun that out into Juice, and basically full-time started selling Juice and supporting Juice. But the two kind of grew together originally. They were separate, because one's a generic library and one's a sort of engine application, but they were kind of born at the same time, and then just went in different directions. For about 2008, though, Mackie, when the financial crisis hit, they stopped releasing updates for Tracktion, so just kind of languished a bit. And then Woody, who had met Jules, who worked at Mackie back in the day, had met Jules, was nagging Jules, saying, "Hey, we should get Tracktion back. It's too good to just kind of do nothing with it. Do you want to work on it again?" And I think by this point, Jules had forgotten the pain of working on it before. It was sort of a distant memory. So it was like, yeah, why not? He'd been doing Juice for a number of years, and I think a new challenge was intriguing to him. So they kind of formed this new company, Tracktion Software Corporation, and released T4. And then pretty much immediately got in contact with me, and I came on board straight away. So, and that kind of was the rebirth of Tracktion. At that point, the target was for yearly updates, major version updates, which we've been doing ever since. And then because the company's grown, and now we do a bunch of other products as well, including software instruments and things, we rebranded the Tracktion DAW to Waveform, to kind of separate the company from product. And also Tracktion Engine is now its own product as well. So that's why it's Waveform, but it's got the same heritage.
Nice. And I think here's a good time for us to talk a little bit just about the traction engine specifically. One thing that I think for people that may be just starting out, or even just for myself, so we throw around these words like data model, engine, and these are terms that are kind of thrown around a little bit, but people may not really understand what those terms mean. And I'm wondering if you could just explain for people what that actually means. So what is in a couple short sentences, when you say data model as opposed to engine, what are we talking about in terms of a DAW on just like a super high level?
So I guess engine is probably not actually a very good word because it's not massively descriptive, but we use engine to describe kind of the all-encompassing thing, in that you want to create stuff like applications. You essentially need an engine to run it on, and that's why it's called Traction Engine. Traction Engine encompasses all the kind of startup, setup, all the data model, all the utility classes, and runs the audio. So that's kind of why it's called Traction Engine. It's the engine that powers waveform, basically. Data model is kind of less tied to the audio side of things, and basically means what does your data look like in the computer, and how is it connected to each other. Again, it's kind of a bit abstract, but the way I like to think of it is in XML terms. So our data model is essentially the definition of Traction Engine based app, and it's an XML type data structure that is kind of hierarchical. You've got an edit node at the top, and then you can contain tracks, and then tracks can contain clips and plugins and all kinds of elements. And you change the data model to affect the audio side of things, and then obviously your UI will update. So it's kind of in that classic MVC style, where you have your model, which would be your data model, the underlying kind of backbone, and you have a bunch of views that represent it, and something to kind of pass information backwards and forwards. I don't know if that answers your question particularly well, but
yeah, it does. And you mentioned MVC, and that's something that's probably a little bit low level to really discuss in depth. But for people that want to know more about data models and what that actually is, then I would suggest you check out MVC, which stands for Model View Control, Model View Control. So that's like an essential. It is very interesting to take something from a view of just creating, like you said, like kind of a play or a toy or a hobby app, and really trying to change your perspective on that a little bit into this MVC type of thinking.
One thing I would say with MVC is, if you look at resources on the internet that do MVC, and like the Apple frameworks are a good example of this, where you kind of have some data, it might be a bunch of floats, and then you create a view controller which will kind of change the model, and then you create your views, which are the UI on top of that. We kind of squash the view and the controller stuff, the model and the controller stuff together, because we use juice value trees. So you basically get the controller listener interface stuff for free. So it's a bit easier to visualize. The way I kind of describe how that paradigm works in Traction Engine is, you have a value tree, which is like a live XML. So that is your data model. And then you can listen to changes in the value tree. So as things get added, removed, or properties get changed, you can observe those, or you can also trigger changes via the value tree. And then you kind of have separate views. So we have a bunch of utility classes or concrete classes that get constructed on top of the value tree, and will mirror themselves to reflect the value tree state. So if you add a track node to the value tree, you will get a track object created.
Mm-hmm.
So that's kind of your data model and concrete class implementation.
Mm-hmm.
And then in the waveform app, we have our UI code, which does a similar thing by observing the value tree and changes the UI and stuff. So you add a track, we want to add a new component that is the track view. But then kind of off to the side of that, you have the audio graph, which can essentially be thought of as a kind of a snapshot of what the data model looks like.
Mm-hmm.
And then that gets handed off to the audio device to be played.
Mm-hmm.
So every time you make a change to the model, it says, right, I've changed, I've moved a clip from this position to this position, or a bunch of MIDI's changed. Now I need to kind of play this new thing. Mm-hmm. So kind of generate a new set of audio nodes, create a new audio playback graph, and pass that off. So the two are kind of separate, which is good because it means the audio can just keep spinning over here, and then your UI, and you can poke things separately. Mm-hmm. So it's really keeping that separation is the key to to most programs, but especially for audio when you've got kind of real-time threads going.
Okay. And when you say a graph, do you mean like the way that the audio is kind of organized? Explain that to me. Like when you say an audio graph, is it like, okay, if I have a synthesizer that's running into a delay, that's running into an equalizer, would that be like a graph? Would that?
Yeah. So it's not a graph as in like X, Y plot.
Uh-huh.
But it's a graph as in a series of connected objects. Mm-hmm. So I don't know if you or your listeners are familiar with the Juice audio processor class and the audio processor graph that comes with it. Mm-hmm. So you can say, I'll create an audio processor graph, and I'll add a node to it, and then I'll add some connections between those. You mm-hmm. kind of create a graph of audio objects. Mm-hmm. The audio graph works similarly in Tracktion Engine, apart from it's not the same class, it's a bit bespoke. Mm-hmm. But essentially what happens is you kind of start at the top and you say, okay, I want to play back these tracks, create an audio graph for me. So it says, right, well, here is a node for this track, and I'm going to iterate all my clips and create a node for each of these clips that can read an audio file. Mm. And then kind of the nodes for the clips will have a specific time that they represent in the edit timeline. And then the node for the clip will have a node to play back the audio file. And that node will deal with the audio file reading and the start and the end position and the offset, looping, etc. So you kind of build these up, and then you might have that feeding into your mixer, which might go through a plugin. So you kind of have this big interconnected set of nodes mm-hmm. that has one top node. Mm-hmm. And then you say, right, this is the thing I want to play. So you pass this to your audio device, and we wrap it in something called an edit playback context, which has the playhead and things like that in it. And then your audio device just keeps spinning and says, right, I want a block of audio now. And we use the playhead to figure out what time that audio should be at. So you get a kind of time window. And then that gets passed through the audio node. And each node says to any node that it contains, hey, get me the data for this. Mm-hmm. And that window kind of gets passed through the audio graph down to the point where nothing has an input. So it might be an audio file reader. And it says, okay, I've got this edit time. It's 1 second till 1.1 seconds. Give me the audio that you represent. And it might read some samples from disk, except it won't be disk, it'll be some memory map thing. And then add it to the buffer, and then that goes, right, I'm done. On the layer up, that goes, all right, well, now I want to apply some gain. And then it goes, right, well, now I'm going to pass that into an effects plugin, might be a chorus, and that goes back up. And then once you kind of unwind this graph, you end up with a buffer that you then just have filled and released to the audio device, mm-hmm. and that goes away until it happens again. So you kind of have this audio graph that's essentially separate from your original data model.
Mm-hmm. And so So that's interesting. So you're basically saying that a node would be like one of the smallest. So an audio graph consists of nodes, and
Yeah.
that a node is one of the smallest instances that you can have. So like audio information that's in a audio clip is that would that be an example of a node?
So nodes typically usually have one input, so you can chain them together. But we do have nodes that will either combine a bunch of other nodes in the sort of time information, like you might have several clips. The clips will be nodes, and they're contained in another node. And we also have mixer nodes that will kind of process all of them. So they're similar but not time-based. So you might have, you might have a bunch of tracks, and they all feed into a mixer node, and then the mixer node says, right, give me some information, and it just iterates all of the nodes it contains.
Yeah. And you talked about the kind of uppermost node that you have at the top of the graph, and that was, what did you call that again?
It's just a node, but it gets wrapped in an edit playback context.
Context. So this would be kind of like the very topmost layer that would have your transport, tempo, and things like that. Would that be correct to say?
Kind of. So the object that we call an edit, which is called an edit for historical reasons. You can think of it as an edit decision list. Sometimes they're called in other bits of software. I think it got called this because it comes from video lingo, which is where Jules was working on video editors at the time. But really it can be thought of as an arrangement or a song or some kind of description of a piece of music.
I see.
So when I say edit, that's what I mean, not an edit as in an action to do something. So the tempo information and all of the tracks and your transport all live in the edit because they're kind of high-level, singular things. Then your edit playback context will be created to be passed to the audio driver, or at least your audio device callback, and it will say, this is the node that I've been given to play, and this is the edit. So it kind of pulls those two things together, but also keeps them separate because you don't want your audio poking directly into your data model because you'll get all kinds of horrible threading and race conditions. So what really happens is when you want to share information across the two, we have a special kind of audio node. So I mentioned the playhead earlier, which essentially converts audio callback time, which is just a continuing clock, just continues forever. And then you hit play, and the playhead goes, okay, now I've hit play, what is the current stream time? So I know where my kind of synchronization point is. And from that, we can figure out if I ask for a block of audio and my stream time is like 1 million seconds, I can convert that to a time in the edit. And that's kind of how the transport works. But in the audio graph, we don't want to directly talk to all of that. So we have, or at least not to the model side of things. So we have a playhead node, which lives in the graph, that does this conversion for us. So it knows about the playhead, and that's all done in a kind of thread-safe way. And that does the conversions, and then passes that on to the rest of the graph. Okay. So you can have several points that do these kind of crosstalk between the data model and the playback graph.
And this is something that we talked about. That so a lot of people say, okay, so what? So the Tracktion engine, well, why use it? And you were talking about these things like thread safety, and so you feel that this is an advantage of using the Tracktion engine rather than building something from like bespoke. Would that be safe to say?
Well, it's taken us 20 years, really, to get to the point we're at. And it's just such a huge amount of work to have to do that to try and do it yourself is really kind of a futile exercise. I mean, if you want to do it because you find it fun, go ahead. That's a fantastic way to learn to do stuff. But if you want to just create an app then having a kind of framework that you can just poke at and say, oh, I want to add a track, and then I want to play some other audio at the same time, so I'll add another track, and I want to load some plugins onto it, so I'll just do that. Or, I want to add automation, and I want to record some audio, because that's got to be done in a kind of thread-safe way by passing blocks onto other threads that then flush them to disk. When you start digging into what an audio application is, there's just so many things that need to work and all need to work together, that using Tracktion Engine basically saves you having to code all of that. And the great thing about that is what an app really is. When you design an app, you're thinking about what it does, the user experience, and the user interface. To me, that's what you give to a user, so that's what you want to be designing. All of the stuff under the hood just has to be there. It's sort of, if you could create a great app that made sound, but you didn't have to code any of the audio full stop, you would totally do it that way. No one does that stuff if they just want to release an app. So by using Tracktion Engine, you can kind of do your design and then just fit it on top of a pre-existing engine that's well tested. So that's kind of the goal of it, and that's useful for several reasons. One is because we've done all of that work already, and you don't have to. You can kind of focus on the high-level fun tasks, and then obviously you've got to sell it and market it, things like that. But it's also good because if you have several apps out in the wild that all use the same data model and project structure and files and things, then you can then share them. So one of our hopes, once a lot of people start picking this up, is you might want to make a mobile app that's a voice memo app or something. So you kind of think, right, this is, you do your app and say, this is how I want it to work. When I press record, I want it to kind of record a file, and then I want it to start. But maybe I want to loop over that. I don't know, maybe it's a musical app and it's a kind of looper thing. But it's a very simple thing on the mobile. And then you say, right, that's my product. But now someone says, right, I want to build that into a song. But you haven't built all of that stuff. You haven't got plugins, you haven't got automation, you haven't got tempo changes, you haven't got possibly, other file reading and writing. So you can say, well, just export that as a Tracktion format project and open it up in waveform. Or someone might create a mastering app, which is essentially just a single track thing that's designed around analyzers and specific tools for mastering, and that's their app. And then you can pass it to that. You might want to create an embedded device, and it specializes in just audio recording or something. Once you're done with that, you want to be able to open it up in the door really simply. So it's that kind of cross-product line that we're kind of really excited about. So other people can say, I've got an idea for an app, but I haven't got 2 years worth of money to fund it so I can build an audio engine and get the disk writing correct, so I can figure out all the musicality MIDI features, or I can figure out how to do Bezier curves automation and all those kind of things. You can just go, right, this is the app that I want to create. Here's a toolkit. Let's just do it. So okay. That's something benefits.
And have people created anything with this, or what? If not, what do you see people creating with this? What would you? I'm sure that when you've released this, you had some type of vision in terms of what you see, what you can see people building. What do you see people building with this?
Well, one of the great things about making a framework is you don't have to do that thinking. You can kind of go, well, here's the tools. I want to see what people make with it. But one example is the Rowland noise app that was released a few years ago, which was kind of built for the blocks to interface with, and is a very kind of live, loopy type app. And if you just showed two people these apps and said, here's Tracktion Waveform and here's Rowland Noise, do you think they're the same thing? And everyone will no, they're completely different. But under the hood, they are. So really, it's that kind of wide range of different things that we can see it being used for. And just with conversations that we've had from people into the NAMM show recently, and getting feedback from people, is loads of stuff. I don't know if you've had a chance to look at some of the demos we've included, but I'm trying to keep those kind of small to gradually introduce elements of the engine. But we've got like a sequencer on there, so you can kind of just put in notes and it will play back through a synthesizer that you can kind of send different files to, and it's like 150 lines of code. Now that would be at least 5 to 10,000 if you were to create just that app, and I did that in about a day and a half. So it's just a demo. It's not fully polished, but it enables you to do that stuff really quickly. One of the other demos is you can play an audio file and then time stretch it or pitch shift it. So my idea behind that was, I used to be a good guitar player. When you're like learning a guitar solo or something, you might want to stretch it down, and with that app you can do that. But it was just kind of really simple. Obviously, it needs a nicer user interface, and you might design it using Objective-C or Swift or something on iOS. But the engine can still be used underneath.
Nice. Is there anything that you feel that it couldn't be used for, that it wouldn't be that it would not be useful for, or do you see it pretty much as all purpose?
Hopefully all purpose. If you've got uses or ideas for it, ask me and I'll say, yeah, it's good for that. No one's come to me with anything and said that I think it would be particularly bad for. The only thing would maybe, now that I think of it, is if you were doing like a Max MSP style thing, it's probably not best suited for that. Basically, if you've got some kind of timeline, it's probably useful for it. But if you haven't got any kind of time information, maybe not the best thing. Yeah. But it could be used, I don't know, if you're creative with it.
Okay. And what do you feel are the benefits of using the engine? So, a person is saying, okay, I'm looking at Tracktion Engine, I'm looking at Juice, I'm thinking about creating something that has some semblance of a timeline. Why use Tracktion Engine rather than using just plain Juice? Is it easier than using Juice? Is there like a comparison that you can fairly make between the two?
It should be easier than using Juice because the terms and concepts that you have are much higher level. So Juice is really low level. If you want to create, if you want to read a file, you have to create a file object, then you have to create an audio format reader, and then you have to kind of pipe the stream into the reader, or just pass the file, and then you have to kind of do your own callbacks to pull that out and to pull out the data. Then you might have to do some resampling to match the sample rate of your audio device, and then you might want to apply some gain effects. Like, you have to do all that stuff manually, whereas playing back a file in Tracktion Engine is as simple as, here's an edit, I want to add a track, I want to add a clip that plays this file, and it's like 5 lines of code, and then you just play it. So the concepts and the objects that you interact with, you are probably more familiar to people who have used audio applications before. So it's basically much higher level. Because it's built with Juice, there are Juice concepts in there, and you can get hold of them. So you kind of can drill down onto the low level. But in terms of kind of making changes to the document, it's all much higher level objects.
And what do you see? So we talked about the Tracktion Engine being generally much of a higher level abstraction than what you get with Juice. What are some of the other benefits that you see of using the Tracktion Engine? So we had discussed all of the difficult things that you have to do, like, for example, just playing an audio file. You have an audio file format. You got to register formats. You got to have a format manager. You got to have like something that holds the actual audio information.
Got to buffer that so you're not pulling from disk every time you want to read a sample and things like that. Yeah.
Yeah. So what are the other benefits that you see of using the Tracktion engine?
Well, apart from the fact that we do a lot of the hard tasks for you, which we kind of already discussed, it's one of the key things is the time it takes to build something. So if you've got an idea for an app, really when you have an idea for something, you're thinking about how do I interact with it? What's the user experience like? What's the UI? When I give this to someone else, how are they going to deal with it? The stuff under the hood that they don't see just has to work. It just has to be there because that's how it's kind of made. If you could create an app without having to write any of the low-level stuff, then you totally would. I would. I don't want, all that stuff's hard. You want to just create stuff that lights up the screen, really, and makes cool sound. So if you've got an idea for an app, but you don't have 2 years to put into making an engine that can do 5% of what Tracktion Engine does, then you can kind of just get up and running really quickly. That's kind of the main goal. And especially if you're perhaps an independent developer or a small company, then you don't need 2 years worth of money to fund people. You can say, right, well, we've got 6 months to build this thing. And, that's much more realistic goal then.
Wow. And what else? So potentially, since this is a higher level kind of abstraction in comparison to Juice, as many people know, Juice can be quite a steep learning curve to get into. Do you feel that this could be useful for things like education and in that sector?
Yep, absolutely. One of the things I found when I was in education was, you want compelling stuff to give to students, and you want them to be able to produce something that they can have fun with, because that's going to keep them engaged. But you also need to teach them the concept. So I imagine Tracktion Engine will be great for that, because it's like, right, well, here's the bare bones of a door, and today we're going to build some UI on top of it so you can teach, good user experience, and perhaps you could teach observer concepts and things like that. But you're all the time doing something interesting under the hood because you've got all this kind of Tracktion Engine power. It can be used to teach more kind of audio engineering concepts like gain staging and perhaps how you pass buffers in and out. And also it can be used as just a demonstration of things, like there's lock-free queues in there, and there's a lot of caching of various objects, and you can use it as an example for how to build concrete classes on top of value trees and how to separate audio processing. So it really is just kind of a good example of a whole bunch of different concepts that you could use in education.
Okay. And what do you see as a long-term vision for this? What do you see in the future for Tracktion Engine?
So because we release our Waveform 10 was the first version to use the current open source version that you can go online and get. When we add features to Waveform because we think it's a good idea, where they belong in the engine, they will go in the engine. So we've talked about performance style things where you have a kind of more on-off type switches rather than continuous timelines features. We've talked about perhaps multi-channel and stereo things. So those kind of things may get added to the engine over time, particularly if they turn up on our roadmap or we have licensees who say, we really want it to do this, all those kind of things. But then there's more interesting stuff we can do, even though the engine is written in C++, because it needs to be fast and it's the right language for it. There's no reason you can't have other languages or other technologies that kind of interact with the engine. So one thing I was doing the other day is just sort of fun proof of concept thing was to have a text editor that is your model. So essentially the value tree just gets spit out to XML. You can modify the text, so I can change a clip start time from 0 to 10, and then your app picks up the changes to that, figures out what you've done, changes the value tree property, and updates your audio playback. So that's a kind of much more live coding way without having to build a complex UI. And so you could really define a very static application just in text without a UI if you wanted to. But then you can kind of take that further. So you could have you could build a UI in React or something on top of Tracktion Engine. So your audio is still nice and fast C++, but your UI is much more declarative style. Or you might be able to take the whole thing to the web. So we can imagine compiling the whole engine to WebAssembly or something like that. Maybe one day Waveform runs in the browser. That would be a cool thing to do. Mm-hmm. And of course, in terms of emerging technologies, Jules, we're really excited by his work on Soul, and we're really keen to see how that can integrate with the Tracktion Engine. So it could be that we just provide really easy access for creating Soul nodes, so you can have a processor that's kind of written in Soul and then just works really nicely with the rest of the engine. Or we might end up creating the whole audio graph as a Soul processor. Mm-hmm. So rather than spitting out our audio node that gets passed to the driver, we kind of spit out this Soul code, which then gets sent to your speakers or your headphones to be played. Maybe that's in a virtual reality environment, so we can do that kind of thing. So we're really kind of interested to see what opportunities that brings. So there's a whole bunch of things that we might do, and we're not sure what we'll do yet, but it will be a combination of what excites us, what we think is fun, and what licensees of the engine want done as well. So we kind of take all of that into account.
That's great. It sounds like some amazing possibilities. A DAW or real-time audio in the browser. I'm sure that's such a hot thing right now. And to see the Tracktion Engine, to be able to build something using that and then be able to run that in the browser, that sounds like a very exciting opportunity. For sure. That
won't happen overnight, though. That's quite complicated.
Yeah, nothing happens overnight.
There's no reason that couldn't happen. Really.
Yeah. Great stuff. Okay. So we talked a little bit earlier about just a little bit of a code overview in terms of the way that the Tracktion Engine works. But is there anything more that you feel that you'd like to add to that, or talk more in depth about the other things that Tracktion Engine offers?
Yes, there's a bunch of things that kind of get asked a lot on the forums and in general. What's a good example of this? Is there any code out there? So Tracktion Engine is actually a good place to just go and look to see how we've done certain things, and as it's a good example for some of the things that you need when creating a releasable app. And just kind of have a look at some of these things. Really, there's stuff for creating audio thumbnails in there that's based on the Juice stuff, but we have a kind of slightly higher wrapper around that. We've got scratch buffers, so you can kind of create audio buffers in the audio thread without having to allocate them. We've got lock-free queues for passing elements around. There's stuff for dithering. Just in the last couple of weeks, we've added there's now a synthesizer in the engine, which we use in examples to create sound. So there's band limited oscillators in there, which you can kind of take a look at. There's stuff for crash tracing that will spit out back traces. Obviously, there's all the value tree utility stuff that we've talked about and I've spoken about in talks before. There's Bezier stuff for automation curves, and a whole bunch of musicality stuff as well, which might be interesting for figuring out separations and intervals between notes and different scales. So there's some interesting stuff that you just might want to look at. Really, the way to kind of get involved with the Tracktion Engine, I'd say, is go to the GitHub, which is github.com/traction/Tracktion Engine with an underscore between Tracktion and Engine. Clone it, do it recursively so you get Juice, which is internal, and then look in the root tests directory, and you'll see there's some scripts there to just build the producer, which will generate some projects from pips that we've got in there. And then you have a whole bunch of demos that you can look at. So we've got a playback demo, which will just play and edit. It's just kind of the simplest thing we could do with it, kind of like the Hello World. We've got pitch and time, as I mentioned earlier, so you can load an audio file and time stretch it or change the pitch. We've got a step sequence demo, which is based around our step clip, so you can kind of turn notes on and off and load different samples into it. We have a pattern generator demo. So one of the things in the engine is, as part of this musicality, you can generate musical patterns, scales, arpeggios, chords, that kind of thing. And now with the Foros synth that Rowland wrote, we have a demo that kind of brings those two things together. You can also play live to it. And I think we've just added or are adding a recording demo, which is a much more DAW-like demo. Mm-hmm. So that has multiple tracks. You can arm many devices at once and record and things like that. So there's a whole bunch of things to go and have a look at. As I say, it's dead easy to go and to grab from GitHub. If you are interested in licensing, I won't talk about this too much, but essentially it's GPL commercial, similar to Juice. Then we have multiple tiers, but go to the website, tracktion.com/develop/traction-engine for details there. I think there's a link from the GitHub as
well. That's great. That's great. Okay. And I did have one question when you were talking about the synthesizer, because so many people are interested in building synths using Juice. Let's say that we just wanted to take the oscillator out of the Tracktion engine, or like pieces out of the Tracktion engine, and use those individually, like within a Juice project. Is it quite easy to do that, or is it something that's a little bit tricky, or?
I don't actually know, because I didn't write that. I think with the oscillator stuff, the oscillators are separate from the synth, so you could just link to that, include Tracktion engine, never instantiate a engine object, and just use the oscillator classes if you wanted to do that.
Okay. I asked because I've been doing this continual tutorial series on building a synthesizer, and one of the things I really want to replace is the oscillators on it. So it would be so cool if I could just take the oscillator from that and patch it in and just use that. So that I might have to take a look at that.
I'm pretty sure you probably can.
Yeah. Great stuff.
Maybe we can do that.
Yeah, that sounds good. Great. Well, I think that's a great time for us to end things. Is there anything else that you'd like to add before we sign off? Where can people get in touch with you if they want to ask questions about the Tracktion engine?
So we love feedback. If you've got any thoughts or ideas or questions or bug reports, things like that, fire them over either on GitHub, or we also have a category on the Juice forum. So that's for discussion and things like that. So that's for the formal Tracktion engine stuff, as I mentioned, github.com/traction/traction_engine for the GitHub. But if you want to get in contact with me, I'm on Twitter @DROAudio. So tweet me on there. Really.
Tweet the Dro. Great stuff. Well, Dave, thanks so much for coming on the show and for sharing all of that with us. I'm sure that's going to be a lot for me to digest, and I hope it is for our listeners as well. So great stuff, and I will see you soon.
Yeah, thanks for having me on. It's been great chatting.
No problem.
All right. Cheers.
Bye.